from MCP. Welcome everyone, I'm Shah, and today I'm going to talk about agent skills and what makes this similar and different from MCP. So before getting into that, I'll just do a quick intro. You might be wondering, who is this guy? Why should I listen to him? It's a great question. So I got into AI about 8 years ago. When I was in grad school, I was doing applied AI research while I was getting my PhD. Then after grad school, I went and worked at Toyota Financial Services, where I was a data scientist. And now for the past couple of years, I've been working for myself, doing various entrepreneurial ventures. So I did AI consulting for a bit, helped over 100 clients, made a lot of educational content on YouTube. So maybe you guys originally heard about me through my YouTube channel. Had this class on Maven, have taught over 150 students, and also been doing a bit of solo app development, built a couple of apps. But let's get into the main talk. So we're going to talk about agent skills and MCP, what makes them similar, what makes them different, when to use each, and things like that. The starting point here is that AI models are getting smarter and smarter. So this is a question answering benchmark called GPQA. And on the x-axis, we have time. On the y-axis, we have performance. And this blue line here is showing the best AI model on this benchmark. So you can see when the benchmark was first released, the best model was getting 30% performance on this data set. But then over time, you can see it creeping up to 50%, then like 60, then 80. And modern models, they're basically nailing this benchmark. So they're getting like near 100% performance on this question answering data set. So this is like biology questions, chemistry questions, physics questions, pretty hard questions. I would probably score like a 60 on this or something like that. But there are other benchmarks. So there's this popular one called software engineering benchmark. So this is like real world GitHub issues and is assessing model performance on those tasks. So you can see it started very poorly. Models were like at 20% performance on solving these real world coding problems. But now modern models are getting like 80% performance on this real world coding benchmark. Models are getting smarter and smarter here, but that's not the only bottleneck when it comes to applying these AI models for real world tasks. And ultimately, the models that we're using are only going to be as good as the tools and the context that we give them. So just to give a specific example of this, if we wanted to use an LLM to find bugs in our code base, if we say review my code base for bugs, send that request to our favorite AI model, it might say something like, I don't have access to your code base. So we're like, oh, okay, let's add a tool to the LLM that allows it to connect to my GitHub account. With this, it'll be able to read through the code, find obvious bugs, but it's going to be still limited because it's only going to be able to read the code. It's not actually going to be able to execute code. So maybe we'll give it another tool that gives the AI a code interpreter and the ability to run tests. So now it won't just find obvious bugs, it'll find silent bugs. It'll find bugs that aren't so obvious from just reading the code. Maybe even if the code runs fine, if you start clicking into the app and start to actually use the app, then the failures come up, then errors start getting thrown. If we give it the code interpreter and some tests, it'll be able to find these bugs. But we can take this one step further. Maybe we don't just want the code to be able to run and work for our specific use case. Maybe we also want the code to follow specific coding standards. So we can give it a set of documentation that tells the model how our team likes to write code or whatever it might be. We can see we went from the AI being completely useless to being very helpful by just giving it the right tools and the right context about how we want it to do this specific task. This is what sparked the innovation of the Model Context Protocol, or MCP for short. So MCP came out in November of 2024, so it's been a little over a year now. And the idea here was to have this open standard, this universal way to give large language models the right tools and context. The analogy that Anthropic uses for MCP is that it's the USB-C port of AI applications. So just like you have your laptop and you're able to connect to all different types of devices using a USB-C port, MCP does the same kind of thing, but for AI applications. Now you can give it access to a web search tool, you can give it access to some knowledge base, you can give it access to your local directory or whatever it is. And MCP is the communication protocol that allows that to happen. happen. The ultimate use case of MCP is that it allows you to connect any AI application, whether it's Claude Code or ChatGPT or Cursor, to just about any tool that you use in your work, whether it's Gmail, Slack, web search tool, Notion, and on and on and on. And if MCP didn't exist, basically Claude or any of these AI apps would have to manually build integrations for all these tools. And on the flip side, every one of these tools, like Notion, would have to build a specific integration to all of these AI apps. But since MCP is a thing, there's this one single open standard that allows all the apps to talk to all the tools. So this is really helpful. To go a little deeper on like how MCP works, it follows the so-called client-server architecture. This is just like if you go to a coffee shop, you are kind of like the client. You're the person coming to the coffee shop and you want to order something. And then the barista is the server. The way this communication typically works is that you will send a request to the server. So you'll ask, can I get a pumpkin spice latte? And the server will send back a response. They'll say, you got it, and they'll give you the latte. This is exactly how MCP works. But instead of a person in a coffee shop and a barista, you have an MCP client, which is the thing sending requests to an MCP server. So the request here might be, can you list all the tools that you have available? And then the MCP server will send back a response listing all the tools and the schema for those tools. This MCP client lives inside the AI applications. It lives inside Claude. It lives inside ChatGPT. It lives inside Cursor. And each client connects to a server, which within it can have prompts, it can have resources like databases, and it can also have tools. So it's like a web search tool, a read file tool, and whatever it might be. This is how MCP works, but there's a problem with MCP, which is that it has a pretty token-heavy communication, meaning that when you send a request to an MCP client, for example, if you want the server to list all the tools it has available, the response you get from the server is actually a pretty verbose piece of text. And it kind of needs to be like this because the AI needs enough context to understand what tools are available, how they work, when they should be applied, what schema it should use to make that tool call, and all that context to actually give the AI a chance to use the tool effectively. While this does give the AI all the info that it needs, it is a lot of info. So maybe you're just trying to list directories and read files, but there are like other tools in the MCP server that are not relevant to the use case, like a web search tool or a code interpreter or reading emails or sorting emails or on and on and on. There could be a lot of tools in the MCP server that are not relevant to your use case, but they're taking up precious tokens. They're taking up precious space in the context window, which not only racks up the cost of your requests that you're sending to the AI, but it also can have a negative effect on its performance. And this is a phenomenon that people call context rot. This is one thing that actually agent skills can help us with. And all this is a folder with instructions in it that's accessed by the agent as needed. So the simplest version of this is we have a folder with whatever skill we want to give to this agent. And in that folder, we'll have a file called skill.md. And then that skill.md file might look something like this. This one's called validate SaaS ideas. It has a description and then it has some instructions here. But there are two key parts of these skill files. There's this so-called front matter, so all this like metadata up here, and then the body of the skill. And so the front matter, this is what's loaded at startup. Right when the agent is spun up, it'll see the front matter. It'll see like this short description of each of the skills available to it. Then the agent has the option to call upon a skill if it is relevant. And only then will the agent load all the additional instructions that are in the body of the skill. This is just like a better way to manage the context that you're giving to the agent. So instead of just like dumping all the context in the schema for every tool you have available in your MCP server, you might have multiple skills for different types of tasks. And even though the AI will see the metadata up front, it's not going to see all the details of that specific skill. But skills aren't just limited to this single file. You can also have additional folders. So maybe you want to put documentation in a folder called references, or you want to put resources and other templates in a folder called assets. You can do that, and you can just tell the agent that these folders exist in your skill.md file, and it'll be able to access it as needed. But you can also include code in these skills. So you can have a folder called scripts. In there, you can have executable code, whether it's Python or JavaScript, and then the agent can call these different scripts and workflows as needed. So just to give an example example of what this might look like, here we have our context window. So this is all the text that our AI can process at a single time. In there, we'll have a system prompt, and then the skills will live inside the context window at startup. So again, this is just going to be that front matter. This is going to be the metadata for all our skills. So let's say we have 5 skills here. Then let's say the agent thinks it's relevant to call skill number 3. Only then will the body of that skill be loaded into the context window. And then if there are specific files or scripts that the agent thinks is relevant to whatever the user is asking for, then it'll load in additional files, or it will execute bash commands to run specific scripts in the scripts folder. And so this idea of just giving the agent the context it needs for the next step is something that Anthropic calls progressive disclosure. So this is just giving the agent enough context for the next step. We've already talked about this, but just to review, the first level of this is the skill.md metadata, that front matter. So this enters the context window at startup, and this will be about 100 tokens. Next, we have level 2. So if the agent thinks a particular skill is relevant to the task, it will grab the body of that skill.md file, and this could be up to 5,000 tokens. And then finally, we have all the other files and folder in the skills directory that the agent can access as needed, and there's practically no limit to the amount of context that we have in these additional folders and files. That's basically what MCP and skills are and a little bit of how they work. So now let's talk about their similarities and differences now that we have that grounding. As we saw, MCP gives tools and context to large language models, while skills, they also give context to agents, but they're not necessarily giving them tools, they're giving them code. So they'll give them executable scripts that they can run as needed. MCP is an open standard that's widely adopted. Skills are now an open standard. So a few weeks ago, this was only available in Claude Code and Anthropic's applications, but I think last week or a couple of weeks ago, they released this as an open standard. While you can use skills in different AI applications, it's still the early days, so it's not as widely used as MCP. One of the key differences, however, with MCP and skills is that all tool schemas are injected into the context window on startup. So basically, when you initialize the MCP server, one of the first things that the client is going to do is to list all the tools the server has available. And so as we saw, this can be a tremendous amount of context that's added to the context window, even if most of it may not be relevant to the use case. While skills, the context and code are only loaded as needed in that progressive disclosure kind of way that we talked about on the previous slide. Another key difference is that for MCP, the LLM